have the fundamental things that you need in order to have some conversations about this. Now, first things first, if I can get everyone's attention, please note that this should say a raised to the m divided by n is equal to the nth root of a all raised to the m. You can also write that as the nth root of a to the m, where that exponent's inside the radical. Now, what I also realized is we need to work on some vocabulary. Vocabulary that I didn't even think about or realize that we need to work on. Because, did y'all know that a power and an exponent are different things?
No.
How are they different, Gavin?
Because one's outside of parentheses.
So give me an example of a power.
Look at the M on there. That's a power.
So the m is actually the exponent.
Oh, well then I don't know.
This is a detail that honestly, and Mr. Lip and I were talking about it last week, he had no clue. And I didn't know this until, I think, last semester, because I had never heard the difference. I always thought that a power was an exponent. It's not. So 3 raised to the second, okay? This is a base, the 3. This 2 is an exponent. But 3 raised to the second, that whole thing is a power.
Oh, so it's the base and the exponent together.
Yeah, I had no clue. I thought power was the same thing as an exponent.
Also, the base and the exponent is
So then
Yes.
together is a
like
power.
the exponent.
Say again.
So them together is a power.
Correct. Have you ever heard that before?
No.
Did you ever realize that before?
I've heard it, but
I heard it, but I didn't realize.
So, and that's the thing, I've heard power, like, and I want y'all to think about this. I'm 29 years old. I've been doing math for a while, right? I knew, and like I've heard power and I've heard exponent, and I thought that a power was an exponent. And this is why language matters. It's important that we attend to these details. So, let's say I do a raised to the m, right? A is my base, and I can use an a just to represent any base that could ever exist. M is my exponent, and again, that could be any exponent that could exist. And then a raised to the m is my power. We all good with that idea?
Yeah.
That being said, let's talk about the nth root of a. Because this is another thing. By the way, did anyone take notes on these distinguishing characteristics? Because those terms matter, and if we don't know those terms, it can affect how we're able to talk about this. Okay? So, this little symbol here with the crook in it, what is that called?
I know it's pretty cool.
Radical. So, here's some important distinguishing characteristics as well. This thing, this number, this expression that's underneath the radical, that is called a radicand. Yep. We're always learning new things. That's called the radicand. You see this n right here?
It's called the root.
It's not called the root.
It's called the radicand.
Nope, this little n right there.
It's called the radical.
You heard me say it earlier because you're like, how do you spell that, Mr. Kenny? Starts with an I. Index. The index of the radical. And you want to guess what the whole thing altogether is called? A root. And so like there's all these terminologies that we don't realize how they're connected, but also how they're distinct from each other, and this is important, right? So when we look at this, this is a root. It is the nth root, the n, the index, defines which root it is. There is a radical symbol, and then a, the base, that thing inside the radical, is called a radicand. And it's important that we know all of these key terms, because what we have learned recently is that we can represent a root with a rational exponent. So we need to know how these things connect. Does that make sense? Okay? So let's start looking at some of these details and explaining what these different terms mean. So what does this mean right here? And I'll read this for you. The nth root of a raised to the n, right, is equal to a. But what is that telling us? Okay, so when the index,
It's equal to the exponent.
well, let's pause for a second. The index of what? What is the whole thing called?
The root.
Okay, so when the index of the root, okay, so when the index of the root what?
Or equal. I mean, it's equal to the exponent.
Okay, so when the index of the root equals the exponent, what happens?
Cancel them bad boys out.
The root cancels out the power. Right? The idea of a root and a power are inverses to each other. Now, will it cancel out if the index is not the same as the power? Or is not the same as the exponent? No. They do not cancel unless the index is the same as the exponent. That's critical to understand and part of what we're going to look at later. Does that clarify some key details that we might have been missing working through this task? Yeah?
Yes.
Okay. So then now, we want to notice, first off, what is a times b called? Or what is that of the root?
Radicand.
So the radicand. So using that proper language, when multiplying factors, when multiplying factors within the radicand, what can we do?
Up in different radicals.
Okay? Let's think about that language a little bit.
Distribute.
Okay, notice, you see right here where we have addition and multiplication, isn't that a higher form of addition? It's repeated addition, so we distribute, right? We've talked about how a root connects to an exponent, haven't we? And so we can distribute that exponent over the multiplication. So when multiplying within the radicand, distribute. Distribute what?
The root.
The root. To the, and I would say individual factors.
Shouldn't say. That's our root.
Again, does that help clarify some of that idea, what we're talking about there? And notice, when we take away the A and the B, it becomes less scary. And I'll say this, I literally remember, it must have been 6th or 7th grade, looking at my teacher, and I remember distinctly looking at what's called the transitive property, right, and the commutative property and all these things, and I told my teacher back then, I was like, I don't like math when it comes to doing variables like that, because that doesn't make sense to me. And I apologize, it's been a long time since I thought like that. And I forget that we haven't been taught to think about, oh, A and B are just numbers. Like, that's something I've been doing for over a decade, well over a decade. If there's ever anything where you're like, I just don't understand what the heck this means, tell me that. I'll slow down, I'll review it, and make sure we understand these things, because I do want you to understand. It matters. And when you break it down into words, it's a whole lot less scary. When I look at this, all this is saying is, hey, if I have one number plus another, then it's the same thing as if I flip the direction. Right? 3 plus 5 is the same thing as 5 plus 3. And that's what we want to recognize, right? It's just giving a general language to these things. So what can we say with number 3?
Distributing
Distributing what?
the roots.
The root to.
Divide.
Let's work on that language a little bit.
Yeah, take it away.
What's happening right here? Notice we have a format, we have a formula right here. When multiplying within the radicand. When what?
When multiplying with them. When dividing within the radicand.
All right, when dividing within the radicand,
Distribute the root to the individual factors.
yeah. That's basically it. We usually think about factors with multiplying, but technically division is a type of multiplication. But when dividing within the radicand, I would say maybe distribute the root to the different terms. I usually leave the term factor for just when we're multiplying. That's the only thing I would change, right? When dividing
Still multiplying still.
within the radicand, distribute the root. And let's say it this way, to the numerator and denominator. Right? Isn't that what we call these things in a fraction?
Yes.
So I think that might be a little bit more clean language. Mm-hmm.
Dirty talk.
Really?
It's important to recognize that in a lot of ways math is a language and we need to be clear about our communication within that language. Otherwise things get muddied. And that's what I don't want. I don't want things to get muddied for you. I want it to be plain what we're talking about. But it is important to recognize. We are learning a foreign language when we want to approach it in such a way. So we got to define things well. So I'm not going to write this down because we should be pretty good on this. But what is number one saying? Actually, I guess I really should have at least write this one down. Number one, what are we saying here?
When multiplying the common bases of the exponents.
So that's actually fantastic language, right? When multiplying with common bases, add the exponents. Okay? And notice, we're just saying that a to the m times a to the n. A can be any base in the world, m can be any exponent in the world, n can be any exponent in the world. So if the bases are the same, it doesn't matter what the exponents are, you add them together. Okay? Now I want to point this out. If these two things are equal, could I then say this? This is known as the converse, where you switch the direction. And this is one of the things that was tripping a lot of us up. We need to recognize as well, or on top of this, when the exponents are being added, you can what? How would we describe what's happening here, right? We are adding the exponents, but then
Equal to.
well, what do we call this thing right here?
Power.
What is this thing?
Power.
So when the exponents are being added, we can split it into two powers. When the exponents are being added, you can split the expression into two powers. Right? And it's just one power has the first exponent and the second power has the second exponent. And it looks like a light bulb's gone off. Is that what's happening there? You're like, oh, that makes sense? Or no, Mr. Kenny, what in the world's happening?
I'm understanding it and it's making more sense as you go. I'm just trying not to zone out at the same time because it's a lot of information all at once.
It is. But that's why we're going back over this before we
Yeah, dude.
keep going with this task, because this is important information. But in thinking about that, looking at number 5. So what would be, and I'm not going to write this down because we already have number 4, but what could you say with number 5? Well,
Subtract the exponent.
I guess, and so I really should have said something else here. When multiplying what with common bases? What are these things called?
Power.
Power.
So when multiplying powers,
with common base.
I feel like that would clarify that language. So
Oh.
here, what are we doing?
When dividing power
When-
comes.
When dividing powers with common bases, what do we end up doing? Subtracting the exponents. Can it go backwards? So when subtracting numbers, or subtracting exponents, we can split it up into two powers that are being divided, right? So we want to notice that you can go forwards, and then you can actually go backwards, and that backwards direction mathematically is known as the converse. If these things are equal, you can always go forwards and backwards to each other.
What's this A equals 1/3 0?
Oh, A cannot equal 0. Because, can you divide by 0?
No.
That's why A cannot equal 0. That's usually a detail that students don't attend to, and I even forgot to bring it up, but that's why they're defining this. You can't divide by 0. Honestly, there technically should be the same thing here, right? Because if I have 0 to the negative 2, then that'd be 1 divided by 0. Can you do that? Anytime that you would have division by 0, that can't happen.
So this is
Okay.
the opposite of natural math, pretty much, in some aspects.
How do you mean?
Because normally if anything's divided by 0, it turns into 0.
Sure about that? Do you have a calculator with you?
No, I do not.
No? Donnie, can you let him borrow your calculator? Type in 7 divided by 0.
0.
Undefined.
Okay, type in 100 divided by 0.
Undefined.
Okay, I guess I was wrong.
That's a common mistake that a lot of students make. So here's what you need to remember. So 6 divided by 2, what does that equal to? 3. Do you know why it's equal to 3?
So 6 divided by 2.
Why would that be 3?
Because
2 times
3.
Okay, so most people only understand it as, okay, the inverse of division is multiplication, so 2 times 3 is 6. But also, what's 6 minus 2? 4 minus 2 again? 2 minus 2 again? How many 2's did I have to take out in order to get to 0? 3 of them, right? 5 divided by 2. Anyone know what that is?
2.5.
2.5? What is 5 minus 2?
3.
Minus 2 again? 1. And so I don't need to take out a full another 2, but I do need to take out half of a 2. And what do I get to?
1 0.
0,
I
right?
don't believe.
What?
Show me one book.